I just want to remind people about terminology. So imagine that you have 3 tasks that you want to do, running them in sequence. You run one first, then another, then another. Concurrency without parallelism, you can actually, for some reason, a task can self-interrupt or be interrupted by force, and you can have a bit of a task and a bit of another task and so on and so forth. You can have parallel tasks but still with interruptions. This is the most common case. So imagine that you are running 10 tasks and you have 8 cores. You can run at maximum 8 at a time, and some will be preempted. If you are lucky enough, or your task, the number of tasks that you have is low, then they can run all in parallel with no preemption at all. But the current scenario, what we have currently in most modern architectures is most probably parallel without any preemption. But some of you might know, the standard Python implementation, this doesn't apply to Cython or Iron Python, has a thing called the global interpreter lock, which essentially means that Python can be threaded, but it means that you can only run a single thread at a time. So if you have many cores, you cannot do Python multi-threading. Well, you can, of course you can, and there are very good reasons to do Python multi-threading, just not getting all the available CPU power available. And in the book I go about asynchronous processing, and I give examples about how threading can be useful even in that scenario. But generally, when you want to do parallel processing, you cannot use Python threads. When I say Python threads, there are several comments here. So the first comment is Python threads bad for parallel processing, but if you use code written in C or Rust or Fortran, that code can realize the global interpreter lock and can use all the threads available. That happens, for example, with NumPy. Well, it might happen with NumPy if NumPy is correctly compiled and linked, where you ask for a function, a linear regression or whatever, and suddenly you see that all cores are being used. And this happens because the NumPy is working with not with Python objects, but with the data that is inside, and it can say, okay, I'm releasing the global interpreter lock, and I'll go and do my stuff in parallel because I know there are no other Python threads working on here, and so you see. Non-Python code can release the global interpreter lock, and NumPy does that, and many other libraries do that, and then they can eventually use parallelism. Another alternative is to use multiprocessing. Is when you want to use pure Python and use parallelism, you use multiprocessing. I personally think lots of people complain about the global interpreter lock and not able to use multi-threading, but to be honest, I don't think it's a problem. You have to be strongly aware of it, but I don't think it is a problem, because if you really need the juice of multi-threading, you probably want to implement it in those inner loops in another language anyway, because if you have, say, 8 cores, you get an 8x performance gain from multi-threading. But if you implement in a lower level language, you probably get 1 or 2 magnitudes. And so I don't think multi-threading, lack of parallel multi-threading with Python is honestly, in my opinion, a big problem. And most of the things that you can do are high granularity things. So you can do it with multiprocessing. So imagine that you have 100 samples to process and you have 8 cores. You can just fork 8 processes at a time, and each process will go through around 20 or whatever. And then you get an 8-fold performance increase at that level of granularity. when you work at very large levels of granularity, you probably be fine with doing multiprocessing. And when you want to do multi-threading, you probably want to use a lower level language anyway.